let's work with some fractional exponents here. Find all real solutions to the equation 2 times x to the 5 halves plus x to the 3 halves minus x to the 1 half is equal to 0. Okay, so how are we going to attack this? The fractional exponents here might cause us a little bit of issue. So let's factor out a factor of x to the 1 half times all of this stuff. So x to the 5 halves is equal to, 5 halves is 2 plus a half. So we can write x to the 5 halves as x squared times x to the 1 half. Multiplying exponents together means that you add together the corresponding exponents here. X to the 3 halves is x to the first times x to the 1 half. And x to the 1 half times 1 gives us, in this case, x to the 1 half times negative 1 gives us negative x to the 1 half. Okay, so we have this line here. Now we should be able to factor at 2x squared plus x minus 1. Quadratic formula would be useful here. We don't see how to factor this, but check for yourself that this factors as 2x minus 1 times x plus 1. So at this point we have x to the 1 half times 2x minus 1 times x plus 1 is equal to 0. So there's 3 separate factors here. And so we know when you have a bunch of numbers multiplied together to give you 0, at least one of these must equal 0. Okay, so we have a couple of different choices here. So our possibilities are, we could have x to the 1 half is equal to 0, 2x minus 1 is equal to 0, and x plus 1 is equal to 0. Okay, so let's figure out what do we end up with here. X to the 1 half is equal to 0. This would be when x is equal to 0. 2x minus 1 is equal to 0. This would be x is equal to 1 half. X plus 1 is equal to 0, and that would give us x is equal to negative 1. But as it turns out, only 2 of these are allowable. And the idea here to figure out which one of these is not allowable is to realize that we're taking, when we write x to the 1 half, this is of course just the square root of x here. Are we allowed to take the square root of all real numbers? So the answer is no, we're not. We're not allowed to take the square root of negative numbers. And so we're only dealing with real numbers here. So we're not allowed to use x is equal to negative 1 as a solution here, because if we plug that back in, we'd be getting imaginary numbers, complex numbers. We don't want that. So there's only 2 allowable solutions here. X is equal to 0 and x is equal to 1 half. Let me wrap up this video by making one comment here when I said that because we have this times this times this is equal to 0, one of those factors must be equal to 0. That's true, but something that is not true here is this statement. If a times b is equal to 1, if 2 numbers multiplied together equal 1, then a has to equal 1 or b has to equal 1. This is not true. For example, if you have a is equal to 2 and b is equal to 1 half, then a times b, 2 times a half, is equal to 1, but you don't have the case that either a is, a and b, or neither of them is equal to 1. The way that this kind of comes out, the place that people tend to get tripped up by this is by doing the following, is that if I were to ask you about, let me say here, x squared minus 3x, let's make this minus 2 is equal to 0. What some people might be tempted to do is to move the 2 to the right-hand side and have x squared minus 3x is equal to 2, and say then we have x times x minus 3 is equal to 2. Either x must equal 2 or x minus 3 must equal 2. So all of these steps are correct, but you can't say x is equal to 2 or x minus 3 is equal to 2. This is not allowed.